Now we move to the cosine rule. As with the sine rule, we can use the cosine rule to solve for a side, or we can use it to solve for an angle, but under different conditions. So again, we have our non-right triangle with vertices ABC and corresponding sides ABC. The cosine rule states lowercase a squared is equal to lowercase b squared plus lowercase c squared minus 2 times lowercase b, lowercase c, cosine angle A. That is, side A squared is equal to side B squared plus side C squared minus 2 times side B times side C, cosine angle A. The cosine rule is used when we have two sides and the angle between them. So in the above, we have sides B and C and angle A, which sits between B and C, opposite side A. Here's an example of that application. Here's our non-right triangle. Angle A, 40 degrees. Side B, 22. Side C, 25. So we have two sides and the angle between them. Now we can find the side opposite angle A. A squared is equal to B squared plus C squared minus 2BC cosine A. That means A squared is equal to B is 22, C is 25, so 22 squared plus 25 squared minus 2 times 22 times 25 cosine 40 degrees. 22 squared is 484, 25 squared is 625. 2 times 25 times 22 is 1100, and cosine of 40 is 0.766, which gives us 266.35, which is a squared. So a is the square root of that, 16.32, the 2 decimal places. Rearranging our formula, we can now use it to solve for an angle. We have a squared is equal to b squared plus c squared minus 2bc cosine A. If we look at the end of that, 2bc cosine A, we can replace that with the a squared on the left. So we have 2bc cosine A is equal to b squared plus c squared minus a squared. Now we can make cosine of A the subject by dividing both sides by 2bc. So we end up with cosine A is equal to b squared plus c squared minus a squared over 2bc. This time we can find an angle when we have no angles, but we have the three sides of a non-right triangle. Once again, here's an example to follow up on that. So we have the three sides of our non-right triangle. A is 21, B is 27, and C is 29. And we want to find the angle A. The formula tells us cosine of A is equal to b squared plus c squared minus a squared over 2bc. So cosine of the marked angle is equal to 27 squared plus 29 squared minus 21 squared over 2 times 27 times 29. All of that works out to 0.72. That's the cosine of the angle. So the angle is inverse cosine of 0.72, which is 43.87 degrees, the 2 decimal places. Here's a flowchart which summarizes what we've looked at. Is the triangle right-angled? Yes or no? If yes, the next question is, does the question involve angles? Yes or no? If yes, we use the trig ratios, SOHCAHTOA. If no, then we use Pythagoras. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Going back to the top, the triangle is not right-angled. Do we know a side and its opposite angle? If yes, we use the sine rule. Recall that the sine rule relies on having an angle and its opposing side. If we don't know a side and its opposite angle, then we use the cosine rule. Recall that the cosine rule gives us two sides and the angle between them, or three sides and no angles. So some basic applications. We can use the sine rule and the cosine rule for measuring distances or angles when we're looking at engineering or construction or some type of survey work. For example, in this first picture, we can see that something has been erected here and we're given certain angles and distances, and we can find another distance within here by an application of the sine or cosine law. Another application here is distance and bearings for marine and aviation purposes. So here's a little map showing a marking of travel of a ship or plane or such with distances and angles, and we can find certain other angles and distances again by application of these rules. Thanks very much for looking, and we'll see you again soon.